Hi, good day, and welcome to my first video on integration. All right, so let's jump right into it. Integration, I always like to tell my students, you could think of it as the opposite of differentiation. So to be honest, I would prefer if you watched the differentiations videos before and then come to integration, because I'll be making a lot of references to differentiation. All right, so let's get started on the first basic formula in integration. Let's say I have an expression and it's ax to the power n. This funny looking symbol here, it looks like a S that got a little bit stretched. This means to integrate. That's the symbol for integration. All right, so whenever we are integrating, all we have to do is add 1 to the power that's hovering over the variable. In this case, the variable is x. You add 1 to the power and then you divide by the new power. All right, so let's put some numbers onto this. Let's say I ask you to integrate 5x to the power 3. And then I have a dx here. I forgot to mention that when you have a dx here, this just means that we're integrating the letter x. That's the variable that we're paying attention to in this particular question. So don't let the dx get to you too much. So let's integrate 5x to the power 3. According to this formula, when we integrate it, we have to add 1 to the power. So let me add 1 to the power. I'm going to add 1 to the power to get 4. And we have to divide by the new power. So my final answer will look like this. 5x, we add 1 to the power. Whatever power we get now, the new power, we divide by that new power. And after you integrate, the integration sign disappears because we are finished integrating. And then afterwards, we put a plus c. The c stands for a constant. For the time being, just accept that we need to put the letter c there. Later on in the video, I will explain why we are putting this c. Now, c just stands for a number. It could be 1, it could be 2, it could be 1,000,000, it could be 600. We don't know the value of c. In fact, if we need to find c, we need more information in the question. Right now, we don't have enough information in the question to figure out the value of c. All right, so let me just put this into perspective with differentiation. Remember, I mentioned integration and differentiation. You can think of it as opposites. Let's say I have y is equal to 4x. Now, so I'm going to make some more space here. I want to do 2 examples side by side. Let's say I have y is equal to 4x to the power 3. And then I have y is equal to 4x cubed plus 7. So it's almost the same expression, except this one has a plus 7. Now let's say I ask you to differentiate, not integrate, but differentiate. If you differentiate y and x, remember I told you in the differentiation videos, you will get dy dx. And remember how this would work? We will throw the power in front. So we're going to throw the power in front. So 3 by 4 is 12. And then we minus 1 from the power. Great. All right, simple stuff. Let's differentiate this expression. This expression is slightly different from this one, except we have a plus 7. So we're going to differentiate this. So dy dx once again. Throw the power in front. 3 by 4 is 12. You minus 1 from the power, so we're going to get 2. But now we have a plus 7 to differentiate. Remember I told you anytime you have a constant and it doesn't have a variable attached to it, when you differentiate it, you are just going to get 0. I am not going to bother to write the 0. So what does this have to do with integration? remember, when we are going this way, we are, well, differentiating, DFF, that's abbreviating differentiation. Of course, when we're going this way, we're also differentiating. So I guess I could put the same ink there. So when we go downwards, we are differentiating. But remember I told you integration is the opposite of differentiation. So that means if the examiner were to give me dy dx, so let's say somebody now walked into the room and he saw dy dx is equal to 12x squared. Right, so let me get another thing here. Block this off here. All right. So they walk into the room and they see dy dx and dy dx, and they notice that, hey, both dy dx are equal to x squared, 12x squared. How would you get back the original equation? Now, we know the original equation is 4x cubed, or is it 4x cubed plus 7? But they don't know that as yet. So, if I integrate, I'm supposed to get back the original answer. So let's integrate this guy. Let's go backwards. Take dy dx, and if we integrate using this formula, we will get back the original answers. So if we integrate 12x squared, well, we have to add 1 to the power, and we'll get 3. And then we divide by the new power. So we divide by 3. 12x cubed, 12 divided by 3 is 4, so we get 4x cubed, which is this answer, right? But what about this guy, the guy who was working backwards in this question? If he were to integrate this, he would get, you add 1 to the power, just like here, and you divide by the new power. And once again, we get 4x cubed. But when he removes the paper, he realizes, wait. He has a plus 7 here. You realize that when you integrate, if there's a missing number here, there's no way to figure out that number given the information that we currently have. So when you integrate, there could be a missing number here. Over here, there's no missing number. Well, the missing number is 0. And over here, the missing number is 7. And of course, if this was 8 or 9, when we integrate, we will never know what the missing number is. So because when we integrate, we are unsure of which number to put, or which number would have been there, we just put plus C as a filler. And later on, given more information, we could probably find C. All right, so I just want you to understand where that C came from. So let's integrate some harder examples. It is pretty basic. If this were my examination, I would never, ever give you something so simple. Let's try something a little bit harder. Give me a few seconds here. Let's see what's going on. All right, let's try this one. Let's say I want you to integrate x squared plus 1 divided by the square root of x, and then I have a dx here. So this just means, hey, I'm going to integrate x's. Now here's the problem. There's a numerator, there's a denominator. Both of these guys here will get divided by the square root of x. You cannot integrate this using this formula as yet. The reason is, to integrate, like if you have plenty things to integrate, you have to make sure all the items are separated from each other. Just like in differentiation. If you are differentiating a lot of items, you want all the groups of x's to be separate. The same thing here. So let me simplify this expression a little bit first before we move on. This means that both of them on top get divided by the square root of x. So we have x squared plus 1, and both of them individually get divided by the square root of x. Just going to put back the dx here to remind ourselves, hey, we're differentiating x. Now, Couple things. You haven't learned how to differentiate two x's at the same time. Now, I agree this group of x is separated from this group of x, so we're making progress. But you don't know how to differentiate two groups of x. And furthermore, just like in differentiation, you don't want the x underneath. The x has to be on top. So, let me simplify this some more. By now, you should know the square root of x is really x to the power a half. So let's get rid of these guys here. Looks a little bit easier to deal with. And from indices, here has a x and here has a x. The bases are the same. And we have a divide. So that means we can minus the powers. So let's minus the powers. Now running out of space here. Okay, so I'm going to go this way when we're going. So we're going to integrate x to the power 2 minus a half is 1.5 or 1.5. And we're going to work with decimals today. And nobody wants the x underneath. So we're going to throw this on top. So we get x to the power minus a half. But we all know minus a half is the same thing as minus 0.5. So since I said I was going to work with decimals, I'm just going to change everything to decimals. Now we can differentiate. This group of x is separate from this group of x. But to be fair, right, to write this properly, if I have the integral sign here, this really means I'm only going to integrate him. To show the examiner that I want to integrate the whole thing, I probably have to put the whole thing in brackets, right? So minor mistake there. So I'm going to integrate him separately, and then I'm going to integrate him separately. So let's move up here. According to these formulas, when you integrate this, you add 1 to the power. So 1.5 plus 1 is 2.5. And then you divide by the new power. Plus, let's integrate him. Add 1 to the power minus 0.5. Add 1 is positive 0.5. You can double check it on your calculator. And then you divide by the new power. Now, I know we have two groups of x. So do not make the mistake and put plus c and a next plus c. It's just 1 plus c. If you have a million items and you're integrating them separately in the same question, you just have to put 1 plus c. And that's it. That's how we integrate a situation like this. This is a question I would consider giving in the exam for 1 mark. All right. Right. So let's get started. Let's try a next one now. Let's try something. Ooh, I like this one. Let's integrate. Why not too big? We're not gonna have space to work it out. Let's integrate open brackets x minus 2 the square root of x squared. Right? And I'm gonna put the dx here. So this looks a little more complicated than the other one, right? So, first things first, do not make the mistake and say, I'm just going to square everybody in the brackets. Remember, squared, and when you have a brackets and a squared outside, it really means two brackets next to each other. A common mistake made by students when they're under pressure in the exam. So, this question can be viewed like this. X minus 2, the square root of x, multiplied by the next x minus 2 square root of x, and then we put our dx here. Great. Let's multiply all these brackets. Just in case you forgot how to multiply our brackets, it's very simple, right? You block this guy here, multiply both of them by x. Then you block this guy here and multiply both of them by minus 2 square root of x. Now, before we jump into this, I just want to point out one thing. If I have the square root of a multiplied by a next square root of the same exact a, we just simply get a, right? So, I'm hoping that you remember that, and you would have learned probably this in early form 4 or the late form 3, when your teacher would have done indices with you. But I'm just letting you know. When you multiply two square roots and have the same number inside them, you just end up with the letter. One of the letters, not both of the letters, just one of the letters. All right. So let's try this out. Let's block him, and we are going to multiply both of them by x. So x by x is, so put this higher here, x by x is x squared, x by minus 2, square root of x is just 2 square root of x, and you just have to put an x there. Right, let's do him. This by this is minus 2 square root of x, and then we put the x here. And let's multiply him by him. Minus and a minus is a positive first of all. And the square root, 2 by 2 is 4. And the square root of x multiplied by the next square root of x. Remember, I just showed you the square root signs will just dissolve away and you will get x. Right. Now, you may have noticed that this looks a little bit complicated. But let's simplify this a little bit before we move on. Right? The square root is the same thing as to the power a half. So square root here is the same thing to the power a half. And x is the same thing. But if you just have x by itself, it's really x to the power 1. So according to our indices rules, whenever you have two same bases and are multiplying between, there's a secret multiply here, you have to add the powers. So 1 plus a half, yes, 1 and a half, or 1.5. So I'm going to write it like that. So please excuse me, I have to erase this. You'll end up with x to 1.5. And similarly here, you erase that and you end up with x to 1.5. Now, these two have the same type of letters and powers. So we can combine these two. Let's combine them. So we have x squared minus 2 minus the next 2 is minus 4x to the power 1.5. That's probably the first time you ever saw that in your life. When you have x to the power 1.5, this come like the letter k and this come like the letter k. Because both of them have the same type of letters, you're allowed to minus it and squash it into 1. And then you have positive 4x here. Right? Let's now integrate. Remember, we're integrating this whole thing. So I should put my brackets to let the examiner know that I'm integrating the whole thing. And I have to put the x there. Alright. I ran out of space here. If I try to do this here, it's not going to fit. So I'm going to clear the top here and then integrate this. So I hope you were making notes. If you haven't made any notes so far, pause the video and do so. Alright. So I'm going to integrate this and put the answer on top. Let's integrate him. We're using these formulas. We add 1 to the power. 2 plus 1 is 3. Divide by the new power. Minus 4. Add 1 for the x here. Add 1 to the power. You will get 2.5. You divide by the new power. Plus 4x. Remember, if there is no power here, it is automatically 1. So if you add 1 to that, you will get squared. And then you divide it by 2. And then you can put plus c. If you want, well, 4 divided by 2 will give you 2. So that could simplify to 2. And if you don't like how you have this whole number here and this fraction here, you can just divide it on your calculator. I'm going to try it here. 4 divided by 2.5. will actually give me 1.6. So if you want, you can erase this. 4 divided by 2.5 is 1.6. And 4 divided by 2 will give me back my 2. Also, I just tell you, sometimes you have a textbook and you look in the back of the textbook and your answer looks slightly different to the answer to the back. X cubed divided by 3 is the same thing as 1/3 x cubed. The 3 just goes underneath. And we put 1 plus c. Right, so that's the answer for this particular question. Oh, I just have one. Well, I forgot to show you one thing. Right? I only remembered it when I was doing this question. If you're integrating 7x, remember I told you there's a secret one there, nobody's going to put it. So when you're integrating, you add 1 to the power and then divide by the new power. That's easy, I showed you that just now. But suppose you're integrating a number by itself. There's no x's here, it's clean here, there's no x. Well, anytime you are integrating a constant, you just add in the letter after. So if it was dx, you put an x. If you are integrating a, you would put 8a. Remember, this tells you what letter you are planning to integrate. So anytime you are integrating a constant, you just, in most cases, will be x. You just put 8x. So sorry I forgot to mention that at the beginning of the video. I was just too excited to do questions, I guess. All right. So let me just check the timer on the camera. How much time has gone so far? Only 21 minutes. Not bad. I think I'm gonna do some other examples in integration, but it's gonna be slightly different. This is gonna be a long video, guys. Sorry about this. Let's integrate some trigonometry functions, and this is where you're gonna make some notes. If you integrate sine x, you will get, let me write this smaller so you'll have all in front of you. When you integrate sine x, right? I have to put the dx here to show I'm integrating sine. You will get minus cos x plus c. Okay? It's kind of like the opposite of differentiation, right? So when you integrate sine, you get minus cos. So that means when you integrate cos x, you will get positive sine x. A lot of people put a negative sign here by mistake. Please learn off these formulas, right? It's very easy to confuse. So let's try something harder now. Let's say I want you to integrate sine 3x. And I put my little dx here. You notice there's a number here now. Over here there already wasn't a number. It was just plain old x. When you integrate sine, I will get minus cosine, right? You put back the 3x because there's a 3x here plus the c. But you see the number touching the x, you throw it outside underneath a 1. So we will get minus 1 too. So if here was a 4, it would just be minus a quarter. If here was a 5, it would be a 5 underneath the 1 to give you 1/5. All right? Right, just double checking it to make sure. Yep. All right. Let's try our next one here now. If I integrate cos 7x dx, I think you're probably going to guess the answer here already. When you integrate cos, you get normal positive sign, but it's sine 7x. You write back the 7x. There's no minus in 1 or anything in this, plus the c. And guess what? Just like in this question, whoever is touching the x, you throw him outside underneath a 1. Great. All right. So pause the video and take down these 4 formulas. There's 2 more formulas I need to show you, right? So you're pausing it now, taking down the formulas. Try to write it in different colors so it makes your formula sheet looks interesting. All right. So I'm going to leave these 2 here. I'm going to write the next one on top, and it's going to resemble these 2 guys. Let's see. If I ask you to integrate sine 4x minus any constant. Let me say it's 1. Right? The point is here is a constant. Right? It doesn't have an x attached to it. Right? So this could be 1, it could be pi, it could be pi on 2. Pi is a constant, even though it looks scary. Pi is just a number, 3.142 or 22/7, how much, whatever you want to call it, right? I'm just saying, here has an x and here doesn't have an x. When you integrate this, you will get, remember when you integrate sine, you get minus cos. So it'll be minus cos. And you put back the full thing in the brackets, 4x minus 1. And only the number touching the x goes underneath the 1. This doesn't really play a part in the question. You just have to write it back once that is a constant. Okay, and you have to put the plus c here. Right? So let's try one for the cosine. Use a different color. So let's say I have to integrate cos, open brackets, 2x plus pi on 2. Well, remember I told you pi is a constant, so pi divided by 2 is still a constant. It don't even look scary. But you're more concerned about the x. When you integrate cos, you get sine, and then you write back the same exact thing in the brackets. Right? And plus the c. And whoever is touching the x goes underneath a 1 on the outside. Great. So pause the video again. Make these notes. You want to have all of this in front of you when you're doing questions, especially past paper questions, which hopefully I will get around to very, very soon. All right. If you have any requests for any particular past paper to start with an AdMaths, let me know. I know a lot of you will prefer the 2019, but to be honest, I don't have a copy of the 2019 paper. I have no idea where to get one from. I checked the bookstores, it isn't out as yet. All right, so if anybody knows where I can get a copy of this 2019 AdMaths paper, please let me know in the comments below. All right, so I'm going to show you how to integrate now with something called limits. Right. It's going to be based on these same formulas that I had with including the sine and cosine. So it's only 27 minutes on the timer. It's going good so far. Let's say that we have to integrate. Let's start with an easy one. 4x to the power 3 plus 2. And I have a dx here. Well, the whole thing is supposed to be in brackets because I'm planning to integrate this whole thing. I have a habit, I forget these brackets. And let's say there are two numbers here. Let's put 1 and let's put 3. So you notice the difference between this question and the other questions immediately. Now I have two numbers here. These two numbers are called limits. The bigger number, please put it always on top. The smaller number, always please put it underneath. Of course, you have no idea what limits do. In my next video, provided I live that long, I will show you the actual use of it. So let me show you how to go about this. Forget the limits for the time being. You just integrate whatever is in the brackets. So yeah, add 1 to the power and divide by the new power. So 4x to the power 4, you add 1 to the power, and then you divide by the new power. And of course, when you integrate a constant by himself, you just put back the letter involved. So I am finished integrating. I do not have to write back my integration sign or dx. But here's the thing. I should simplify it. 4 divided by 4 will cancel out, obviously. And here's what you do now. Let's pay attention to these limits. You see when you have those two numbers, you put a big square brackets like this. You'll see it in your textbooks also. And then the numbers slide across to your right. 3 goes zip, the 1 goes zip, goes outside the brackets. Here's what you're going to do. You are going to replace both x's at the same time with the letter 3. If you had 1,000,000 x's, you will replace all of them at the same time with 3. Then, afterwards, the number underneath, you are going to do the same exact thing. You're going to replace this x with 1 and this x with 1. And guess what you're going to do? You're going to take the top answer and minus the other answer. So let me show you what that will look like when we write it out. We have x to the power 4 plus 2. Remember we said we're going to replace both x's with 3. Erase the x's and replace this with 3. Please use brackets when you're replacing something. Right? Now, when you do this, put it in a square brackets. And then, please put a minus sign here. Please. Right? Don't forget to put the minus sign here, right? Because we are minusing both answers. And in our next big square brackets, please remember to put these brackets, right? It could make or break the question. Okay? Here we have x to the power 4 plus 2x. And we said we would replace both of these x's here with 1 now. Right? Tell me if that makes sense. It was the same thing I was saying up here. Replace both of them with 3, then replace both of them with 1. And we plan to minus both of them, and we put this in our brackets and this in our brackets. Let's work it out. All you have to do is work out this brackets, and minus the two answers, and we're finished. Alright. 3 to the power 4. I should know this. 81. 81. 2 by 3 is 6, and we have to add these two. 1 to the power 4 is 1. 2 by 1 is 2. 81 plus 6 is 87, minus 1 plus 2 is 3. And we have to minus both of these answers. 87 minus 3 is 84. And that's our final answer for this particular question. So that is how you do limits with integration. Like I said, I've said it before, this question is too easy. I will never, ever give you that in an examination. I will always give you something a little more challenging. Let's try something a little more challenging here. A question that one of my students gave me. Alright, let's see. I should really bring water while I'm doing these videos. Anyway, excuse me for 1 second. I'm gonna run to the fridge, get our water. Alright. Proof I wasn't lying. Here's the bottle of water. Alright. Okay. Alright. Next question. Let's try. Oh Lord, you're not gonna like this one. 8x minus 2 divided by the cube root of x dx. First things first, we need everything to be separated. And this cube root of x, well, from my differentiation videos, you should know by now the cube root of x is really x to the power 1/3. So let's change that up one time. And everybody on top gets divided by x to the power 1/3. So we have to separate that out. Let's see if I can do it here to leave more space down here. You have 8x minus 2, and each person here gets divided by x to the power 1/3. X to the power 1/3. And I have to put back this dx here. Alright, so I'm going to integrate both of them. But we have a problem with both of them at the moment. Here we have two x's, and here the x is underneath. Remember, x by itself is really x to the power 1. And if we throw this on top, we will get x to the power minus 1/3. This one here, the two x's are separated by a divide sign. So our indices rules would say, take 1 and minus the 1/3 to get 2/3. So let me take that and write what we will finally get here. So we are integrating between 0 and 8. We will get 8x to the power 2/3. 1 minus 1/3 is 2/3. And we said we would throw this x to the power 1/3 on top to get x to the power minus 1/3. Keep putting my dx here. I need to put my brackets here to show I'm integrating the whole thing. So let's integrate now. I have a good feeling I'm going to have to work with fractions for this question. It's not a good idea to work with decimals when it's 2/3 and 1/3, because 2 divided by 3 is 0.666666666. Reoccurring, you ready? I know we could round it off to 0.67 or 0.667. Let's try our best not to round off too much until the end of the question. So let's work with the fractions. So you're going to bounce up some shortcuts. So let me show it here one time. If I have 5 divided by 2/3, when you bring a fraction on top, the divide will change to a multiply and the fraction visiting on top will flip. So the 3 will go on top and the 2 will go underneath. So I will get 15 on 2. So a little shortcut is something to note mentally. It could save you a lot of time in the exam. Instead of saying 5 divided by 2/3, and then in primary school they would have say change the divide to a multiply, flip it. That's going to take you forever, right? Just remember this. Bring it on top, flip it. Okay? Make a mental note. Alright, you're no longer in primary school. You have to do things quicker. So, let's see. Add 1 to the power here. And whatever we get, we divide by the new power. So 2/3 plus 1 will give us 1 and 2/3, right? So, which is really 5 on 3, right? 1 and 2/3. So we will end up dividing by 5 on 3 minus 1/3. Erase this brackets here. Plus 1 will give us 2/3. You can double check it on your calculator. And then we divide by 2/3. All right. So let's simplify this mess here. All right. So we are finished integrating. So my next line, I won't have the integral sign. So it will be 8x to the power 5 on 3. And remember, this will go on top to give you a multiply by 3 and divided by 5, right? It goes on top. I'll simplify that in a little while. This 2/3 will go on top and flip, so we get 2 multiplied by 3 on 2 x 2/3. Because remember, we add 1 to this, right? Cool. Let's simplify this. This side looks a little bit easier. Bam, bam. Over here, 3 multiplied by 8 is 24, so you end up with 24 divided by 5. All right, run out of space here. Make sure you have you wrote everything down here, because I'm going to have to start to erase to make space. All right, so pause the video, take it down, and then move on. All right, let's see. All right, so let's simplify it up here. We said 3 by 8 is 24 divided by 5, x to the power 5 on 3. Some of you are probably wondering, how do you write a power as a fraction on a calculator? I will try my best to show you. I'll bring the calculator close up to the camera. 3 here, x to the power 2/3. All right. Some really terrible handwriting there. Oh, I think I wrote it slanted. Alright, doesn't really matter, I guess. What were the two numbers in the beginning of the question? 8 and 0. Remember, those were the limits on the question. So here's what we're going to do. Take the 8, replace both x's here. Then take the 0 and replace both x's. And we have to minus both answers. All right, so let's do some replacing. Remember, when we do this, I'll be constantly begging you to remember to put these square brackets right? Don't forget to put the minus sign in front the brackets, okay? In between the brackets, sorry. All right, so let's do some replacements here. Okay, so let me write it, and then I'll repeat that line. All right. 24. Yes, no, 1 second, 1 second. I'm coming. All right. Now let's replace some x's. Erase this x here. Replace it with 8. Replace this x also and replace it with 8. I remember to put my brackets. Replace this x here. You'll put 0. Replace this x here. We're going to get 0. All we have to do is work out this, write down our answer. Work out this, write down our answer. And then minus the two answers. So, let's see. Alright. So I'm going to show you. Hopefully you can see everything here. Right, that looks great there. Okay, hope you're not getting any glares there. So, it's 24 divided by 5. I'm going to press equal. So 24 divided by 5 is 4.8. Now I have to multiply it by 8 to the power 5 over 3. So the upside down V there, that when I press this button here, the YX button, that's to the power. There are two ways you can type in the fraction like this. 5 ABC 3 and press equal. That will give me how much? 153.6. So when I work out this guy here, 153.6. Let's work out the other one using a slightly different method. Now remember, you can't say the 3 by 8 is 24 and then put it to the power, right? That 8 is separated from the 3 until we put it to the power 2/3. So it's 3 multiplied by 8 to the power. And if you want to use the fractions button, you could say 2ABC3 or open brackets 2 divided by 3 close brackets. If you want to put the fraction in brackets, if you want to put the fraction using the divide sign, you have to put the whole fraction in brackets. Notice there's a open brackets, the 2, and then the 3 close brackets. That will give me 12. Okay? I'm just double checking it. I was standing on a chair balance and doing that. 8 to the power. Sorry, 8 to the power 2 divided by 3. Yeah, seems that we're correct. Minus over here. Now, this one is going to be easy. 0 to the power anything is 0. 0 by anything is 0. 0 to the power anything is 0. By 3 is 0. So, this is irrelevant here. So, we have nothing to minus. So, just to work out here. 153.6. 153.6 minus 12. Our answer is 141.6. Alright? So that's our final answer for this particular integration question. Alright, I think the camera shifted here a little bit. Just re-shifting it. Alright, should be good there. Hope I didn't miss anything. Alright, I just want to point out one thing again before I clear this, make a next video. The reason I so want you to put these things in brackets and a minus sign in between. If in one brackets we have the number 5, let's say when we worked out this brackets we got 5. We didn't get 5 today. And you have a minus sign, and in the next brackets we got minus 3. Remember, this minus sign here is mandatory. So if in the second brackets you get a negative, 2 negatives would touch to give you a positive, and we will get 8. Right? So that's why I keep begging you to put the brackets and making sure you put the mandatory minus sign in the middle. Alright guys, so I really hoped that you understood integration using the basic formula and with limits, right? And of course, If you're from Trinidad and Tobago and you need any extra lessons in almost any subject, you can always give me a buzz. So until then, take care and stay for video 2 on integration. Right? Sorry, I just re-angling this so you could see the 513 there. I was talking about it, but I don't think you all saw it. Bye. Hi, and welcome to my second video on integration. All right, now today I'm going to concentrate on doing more questions on limits. Now, just in case you don't remember what limits were, that's when there was a small number here and a bigger number on top. Now, I never really actually explained what limits are used for. So we were just practicing limits, getting answers, but I always like students to know what can it be used for. And of course, questions like this do actually come in the exam, and they hold quite a lot of marks. All right, so this video is going to be very long. Unfortunately, it might cross more, well, it might be about an hour long. All right, so to make things interesting, I have a bottle of water. I usually get a little thirsty. Whenever I get thirsty, I'm going to shuffle these cards. I'm going to pick a card, and if I get an ace in any suit, I will be allowed to drink water. So let's see if I'll get a... Oh, that really wasn't planned. All right. All right, so let's get started. Here we have a graph, an x and a y axis, and I am giving you the equation of this, the equation of the graph. Now, the equation is y is equal to 4x cubed minus 6x plus 3. I actually don't know how this graph will look in real life. I just drew a sketch. But that won't affect the question. Here's the question the examiner might ask you. He will say that when you have this graph, and he'll give you the equation, most likely, he will say that between 1 and 3 on the x-axis, so let me just draw that here. Obviously, between 1 and 3, if I were to shade this region, that shaded region must have an area, right? Now, this shape here is not exactly a rectangle. It's not a triangle. It's not a trapezium. So it's actually a curve. It's curved on top. It's flat underneath. And to find the area of that region, we cannot use simple formulas like base by height or base by height divided by 2 or length by breadth. We actually have to use integration to figure out the area. So how do we figure out the area? Well, the examiner gave us an equation. So we're going to write the equation for, I should write it a little smaller so the whole thing can fit. The formula is 4x cubed minus 6x plus 3. And here's what we're going to do. We are going to integrate this expression. So if I plan to integrate it, I have to put the brackets on dx. You all remember what the x means? I am integrating the letter x. And since I want to find the area between 1 and 3, guess what? That is where our limits will be. 1 and 3. So I'm guessing that you can do this question on your own, but I will help you with it. So let's begin to integrate. We're going to use this formula here. This is the one where you add 1 to the power and divide by the new power. So 4, add 1 to the power, you will get 4, divide by the new power. Minus 6, remember the x here has a power 1, that's understood. You're going to add 1 to the power and divide by the new power. And if you have a constant by itself, when we integrate it, we just put back the letter x because we're integrating the letter x. So we are finished integrating. You put your big square brackets, 3 and 1. All we have to do now is replace all the x's. We have 3 of them today with the letter 3 And then we have to replace all of them with 1. And then we minus both answers from that point. All right, so I'm not sure how I'm going to get all of this to fit on this whiteboard, but we're going to try our best. Let's see. I could probably squeeze it in underneath here. So, I can simplify this before we move on. 4 divided by 4 will cancel out. 6 divided by 2 will give us 3. And well, we have 3x here. That cannot be simplified. Alright, so I can actually make more space underneath here. Right? Just give me a few seconds. Yeah, I really I hope nothing gets cut off from the video. Alright, well, so we're going to replace all of them with 1 eventually. So yes, I think I have enough space underneath here now. Let me write this. X to the power 4 minus 3x squared plus 3x. Put it in a big square bracket. Minus the other set will be x to the power 4 minus 3x squared plus 3x. Right. So we're going to replace all the x's here with 3. Bam. 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 All right. And then we have to replace all the x's here with 1. That's this one here, in case you're wondering. Okay. Now you notice I put it in brackets and I put my mandatory minus sign. And remember, the bigger number always goes on top and comes first. The smaller number goes underneath and it comes second when we're expanding it out. All right, so calculator time. Let's see what we have here. Oh, I wrote something very stupid here. I forgot the 3 here. All right, so let's go here. 3 to the power 4 is 81. 3 to the power 4 is 81. 3 squared is 9. 9 by 3 is 27. And 3 by 3 is 9. Cool. Let me work this out one time. 81 minus 27 plus 9. You're going to get 63 here. Mandatory minus sign. This is going to be easy here. 1 to the power 4 is 1. 1 squared is 1. 1 by minus 3 is minus 3. 3 by 1 is 3. Minus 3 plus 3 is 0. Plus 1 is 1. 63 minus 1 is 62. That means the area of this region is 62 units squared. Remember, area is measured in, well, if it's meters, it's meters squared. If it's centimeters, it's centimeters squared. Right? So since we don't know the units, we just call it units squared. All right. Pretty easy stuff there. All right. Let's try another question. Okay. Okay, now there's one type of integration that I never, well, it's only now I actually remember to show you all, but no harm done. Let's say you have to integrate ax plus b to the power n. And let's say it's a huge power, like 10 or 12, so we can't really expand out the brackets, okay? How do you actually go about a question like this? Well, you do the same thing you would normally do. You would add 1 to the power, just like in this question here. You add 1 to the power. You divide by the new power and the number touching x. Remember, this only works for x and not x squared, x cubed. Just plain old x here. Whatever is touching x, you drop a copy of it downstairs. And that's how you integrate a situation like this. So, let me put some numbers into this now. Let's say I ask you to integrate, open brackets, 4x minus 7 to the power 11 dx. To integrate this, you add how much to the power? We add 1. We're going to get 12. The new power, we throw it underneath. And whoever is touching x, we throw him underneath as well. And that's it. And 12 by 4, we can simplify that to 48 if we wish, right? So we can erase that and put 48 instead. Of course, sorry, plus C. You notice in all of these formulas, I forgot to put the, not really forgot to put the plus C, it just couldn't fit now, but all of these formulas have a plus C at the end of them. The only time there is no plus C is when there are limits, like when there's a number underneath and a number on top. You notice in all the limits questions, I did not put a plus C. The only time there's a plus C is when there are no limits. Okay? Great. I'll probably be constantly reminding you, sorry, getting thirsty again. It's a lot of talking. So let me see if I get my drink of water today. Have to get an ace. Let's see. Alright. No water. Just our next question. Oi. Alright. Rules are rules. Let's try another question. Okay. Let's try, oh, this is a good one, right? Let's say I have a graph. Here's X and here's Y. And we have a graph going like this. It's swerving downwards. And the equation of this graph is 1 divided by the square root of 5x plus 1 with a dx here. So that's the equation of this particular graph. And they want you to find the area between 0 and 2. So that should be this shaded region here. We want to find the area of that region. So guess what? We have to integrate this. And when we integrate it, we're going to integrate between 0 and 2. So let's try it here. We're going to integrate between 0 and 2 and 1 divided by square root of 5x plus 1. First of all, that square root is going to cause problems. But we know that square root is the same thing as to the power half. So we put this whole thing in brackets and put to the power half. I'm already supposed to have a dx here. I'm constantly forgetting that we're integrating dx. So, another problem. The x's are underneath. I think we should throw that on top first before we integrate. So, let's throw it on top. The positive a half will become a negative a half. And we'll join the 1 on top. But 1 multiplied by anything is itself. So it will look like this. 5x plus 1 in brackets. And we have a negative a half as the power. And that constantly annoying dx. Alright. Okay. Time to integrate. Integrate this using the new formula. We have a power. We're going to add 1 to the power. Divide by the new power. And the number touching x will jump underneath to meet it. So when we integrate, it would look like 5x plus 1 minus a half plus 1 is positive a half. The positive a half goes underneath and the 5 joins it as well. Alright. We have finished integrating. So we can put our big square brackets and put the 2 and the 0. Alright. So I guess we should simplify it before we put in the 2's and we put in the 0's. Half multiplied by 5 is 2.5. Right? So I'm just going to erase this and put 2.5. I know it looks weird to have a decimal underneath a divide sign, but remember our calculator will be doing most of this calculation here. Right? If this makes you feel uncomfortable, you could write it like this if you wish. 2.5 is the same thing as 5 on 2. Remember I told you when this goes on top, it will flip, so you will get 2 on 5. Right? So you can write it like that instead. It's really not going to make a difference because the calculator will know how to handle the decimal. Alright, so throw in the x time. We're going to replace, it's only as complicated as this looks. You know, it has one x to replace, so we're going to replace it with 2. And then we are going to replace it with 0. So let's try it here. Should have enough space. I'm going to write back the whole thing. I'll write a little bit small. Sorry about that. Alright. I'll put in my brackets just now. Alright. Remember, this is supposed to go in brackets. And this is supposed to go in brackets. And you have the mandatory minus sign. In the first one, we have to replace x with 2. In the second one, we have to replace the x with 0. I can write this 2 a little better here. Alright. So, time, well, 5 by 2 is obviously 10. So all I have to do is say 10 plus 1 is 11. And then say 11 to the power a half on the calculator. And then divide the answer by 2.5. So let's see if I can do that. 10 plus 1 is 11. So let's start off with that. Let me see. Hope there's no glare. Alright. 11 to the power a half. To the power, well, a half is the same thing as 0.5. Press equal and divide it by 2.5. I got 1.33. So over here is 1.33 minus, and over here 5 by 0 is 0, plus 1 is 1. 1 to the power half is still 1. 1 to the power anything is 1. Right? And then we have to divide it by 2.5. So 1 divided by 2.5 is 0.4. We just have to minus these two answers. 1.33 minus 0.4 is 0.93. So the area of this region is 0.93 units last squared. Alright, so let's try another question. Alright, I really need a drink of water now. I really need a drink of water now. Alright, I think I should be allowed triples. Triples. In one of the triples, if I get it, I deserve water. Alright, let's see. Alright. Oh, in the next question, I'm going to show you how to find the area between two graphs. So not just one graph, two graphs. Then I'm going to show you some trigs, some sine, tan, and cosine. Alright, I feel lucky with this one. What? It's not even supposed to be here. Alright. That first one doesn't count. Oh, crap. Alright. I deserve water. Agua. Yes. Okay. So, the next question, when I'm drinking the water, I'm going to draw this first. Then take my water. Okay, so that's the X and the Y axis. And let's check the camera to make sure it looks like it's shifting. No, didn't shift much. Everything is still good there. I'm going to have two graphs now, and I'm going to color code them. One of them is going to be a straight line. The equation of the straight line one is going to be y is equal to 5 minus 2x. And the curved one, I'm going to put it in red. And the equation of the red one is going to be x squared plus 2. 1 second. All right, well deserved. Okay, so let's assume that these two graphs meet at this point and they meet at this point. I want you to find the area of the green portion. In other words, the area between the two graphs. Okay, remember the other questions didn't have a second graph. They were just asking you for the area between the graph and the x-axis. This one is in between two graphs. Now this question can come in an easy way or a very difficult, well, a little more difficult. Here's the thing. You don't know where these two graphs meet. You need to figure out where it meets on the x-axis. So you need this value here. And if I drop this straight down, there will be a value on the x-axis here. The examiner could be nice and say, hey, this value is probably 2 and this value is probably -4. He could be nice and tell you the two values. But let's assume that he doesn't. You know what you will have to do? You will have to solve these two equations simultaneously. When you are solving a simultaneous equation, when you solve it, you're already trying to figure out the coordinates of where the two graphs meet. So let's assume that you solve these two equations simultaneously, and when you solve for x, you're going to get two values. And over here the value is 1, and over here the value is -3. Right? I honestly can't remember any question if they made you solve it simultaneously, or if the examiner was nice and he just gave you the two values. I really can't remember. All right, so let me show you how to find the area between the two graphs now, once we have the coordinates of the boundaries, the limits of the situation. There are two graphs here, right? A red one and a blue one. So I am going to call the blue one fx, right? And I am going to call the red one gx, because an equation is really a function at the end of the day, right? Now, you're going to have to minus the two functions. And I'm going to show you how they write the formula in most textbooks, right? You have to take the two functions and minus it. So it's either you say gx minus fx or fx minus gx. It makes a big difference of which one you put first. So how do you figure out which one goes first? Well, you have to look at the region they are talking about. I don't care about outside the region. So in other words, I don't care about this region and I don't care about this region. The shaded region is in between these two coordinates, not outside, in between. In the shaded region, which graph is on top? The blue or the green, or the blue or the red? It seems to me the blue one is on top and the red one is underneath. But if you look outside the region, sometimes it will be the opposite situation. Outside the region, the red one is on top and the blue one is underneath. I don't care about outside the region, I care about inside the region. So here's what. The one on top, you always put it first. So the blue one is on top in the shaded region, so it's fx minus, and the one underneath goes second, gx. You have to minus these two functions, then integrate it between let me write the wrong thing here. 1 and -3. So you get an idea of what not to do. Remember I told you the smaller number has to go underneath and the bigger number has to go on top? -3 is actually smaller than +1. It has to be the other way around, right? So put the -3 here and the +1 here. And believe me, when you're doing this, right, you see, when you're minusing it, you're minusing the whole gx. So if this gx, you should imagine it in brackets now, because the whole thing will be subjected to this minus sign. So be real careful about it, right? And of course, we're integrating dx, right? So anyway, let's minus the two functions and then integrate. Okay. How much is fx? Fx is 5 minus 2x. We have to minus, and then we're going to put gx. Gx is x squared plus 2. You see, if I write it like this, I'm going to get this question wrong. Because when I write it like this, it looks like only the x squared is minus. But remember, this whole function is subjected to this minus sign. So you have to make sure and put the whole thing in brackets. Otherwise, you will get a wrong answer. So we have 5 minus 2x Minus by x squared is minus x squared, and minus by positive 2 is minus 2. You see, if we didn't put that brackets, you would have left this as positive. Now, let's simplify this. 5, we can minus the 5 and the 2 to get 3 minus 2x minus x squared. Now, we haven't integrated as yet, you know. We have only simplified this part of the problem, and we said after we simplified it, then we would have integrated. So, let's do that now. Let's integrate. So, I'm running out of space once again, so I'm going to erase this over here and write back this here now. So we have 3 minus 2x minus x squared, and of course we are integrating which letter? Dx. Right, autocorrect, bam, bam, bam. Right, cool. Time to integrate, right? I know I keep forgetting this brackets here to show I'm integrating the whole thing. So, let's integrate. When we integrate a number by itself, a constant, we just put back the x. Minus, well, x here is really x to the power 1. So you add 1 to the power. So we add 1 and then divide by the new power. 1 plus 1 is 2. So this and this will cancel out definitely. So we get x minus x squared. For this one here, we add 1 to the power, we will get 3 divided by the new power. So we get minus x to the power 3 divided by 3. And since we have limits, we do not put a plus c. Instead, we put our big square brackets 1 and minus 3. And I think you know what we're going to do from here now. We're going to put 1 into all of these guys here, and then minus 3 into all of these x's here, and minus the top answer from the underneath answer. So give me a few seconds here just to lay this out on the board. You could take a chance and see if you could get the answer before me if you wish, right? So while I do this, you could probably jump in and punch everything on your calculator and see if you could get this out before me. Right? Minus the mandatory minus sign in between. All right. Just double checking something here to make sure I haven't written it. I did double checking my work in here to make sure I didn't do anything wrong. Doesn't seem like I did anything wrong. Alright. Nope. Everything seems to be correct. Okay. Alright. So let's start substituting in. I'm going to put the 1 in here. Erase all the x's. Put a 1. Please remember, when you're replacing something in maths, put it in brackets. Okay. This x with minus 3. This x also with minus 3. This x also with minus 3. All right. This looks messy. All right, I hope you got your answer before me. Let's see what we got here. We'll use blue here. 3 by 1 is 3. 1 squared is 1. 1 to the power 3 is 1. So we end up with 1/3 here. Alright. Minus 3. 3 by minus 3 is minus 9. Minus 3 squared is positive 9. And a minus sign is waiting outside. So we get our next minus 9. Minus 3 to the power 3 is minus 27. 27 divided by 3. Minus 27 divided by 3 is minus 9. But then we have a minus sign here. So we're going to get positive 9. A lot of 9s. Alright. Good news is... let's start back from here, then I'll tell you good news. 3 minus 1 is 2. 2 minus 1/3 is 1 2/3. Have a minus sign here. This minus and positive 9 will cancel out, leaving you with minus 9 here. That's this guy. Notice two negatives touch, so you're going to get a positive. So two negatives. I'm going to erase this. Hopefully you'll see it. You get positive here. Now let's make sure that showed up on the camera. Yes, it showed up on the camera. Okay. We just have to add these two and we're finished. Well, 1 2/3 plus 9 is obviously 10. And 2/3 units squared. Alright, so that is how you find the area between two curves or two graphs. It doesn't have to be two curves. It could be a curve and one straight line, but it could be two curves if you wish. Alright, erase this. Let's try another question. You know, up to now I haven't done any limits questions, I believe, with trigonometry, you know, with sine and cosine. So I think I should do one of those now. Oh, forgot to check time on the camera. Oh, I can't see. 1:30 something minutes, 31 or something it looks like. All right. Oh, I was gonna drink water, but I can't until I do this. All right, triples. 1, 2. Who keeps putting this? No water today. No water right now. Okay. Let's try a trigonometry one. No? I have to go through some basics with you. Alright. You see this little chart here. Some of you may have recognized, may have realized I have a table here and I didn't put anything into it. In maths, well, in life, there's more than one units to measure something. For example, if I ask you what's the distance between my two hands here, some people might say it's 40 something centimeters, and some people might say it's 1.5 feet, or somebody might say this looks like 1/3 of a meter. The point is, there are more than one ways to measure something. When we're measuring angles, most people are really accustomed to degrees. Like they'll say, hey, the angle between these two, well, my hands here might be 30 degrees, this might be 45 degrees, this might be 180 degrees. But there are other ways to measure angles. Degrees, and some people use radians. And of course, there must be a way to convert feet to meters or meters to centimeters. Same with angles. If I am measuring something in degrees, there must be a way to convert it to radians. And of course, if there's radians, there must be a way to convert it to degrees. So I'm going to give you, I'm not going to go through the formula today, but I'm going to give you a little chart to remember, right? There's a few values we're going to encounter today. 2 pi is the same thing as 360 degrees. So that means pi is the same thing as 180 degrees. So if you see pi on 2, that is really 90 degrees. Of course, there are much more values you need to learn off by heart for the exam, but as I go along with the question, I'm going to introduce it. So if you see a different pi on something, like pi on 6, at that point in the video, I will tell you how much degrees it represents. Don't worry, eventually I will do a whole video on radians and degrees. That's a whole topic by mathematics, right? So I haven't done it as yet, but I plan to do it. Okay, so let's get started. Let's say I have, let me draw a sine graph or something, right? Let me draw a graph here. A lot of y'all don't know how the sine graphs look and whatnot. You won't know as yet, right? I don't expect you, because I haven't done a whole video on trigonometry, well, trigonometry graphs as yet. Let's say I have a graph and it looks like this. Let me use blue for this. Right. And I tell you the equation of this graph is y is equal to sine 2x. All right? So, and I want you to find the area between, let's use this one here. Let's assume here is pi on 6, and over here it's I use this one. Pi on 2. So I want you to find the area of this region here for me. Now remember, sine and cosine were made for angles. They work with angles, like sine 30 degrees or sine 40 degrees. So the x-axis is being measured, is a measurement of angles. But a lot of time in the exam, they don't use degrees. They use radians, right? So you have an option on the calculator to change it from degrees mode to radians mode. I highly recommend that you do not switch the mode of your calculator. Sometimes you switch the mode of the calculator, and in the stress of the exam, you forget to change it back to degrees. And then you end up getting a whole set of questions wrong, right? It happened to me once in an exam. I don't want it to happen to you. So when you see pi on 6, I am letting you know that pi on 6 is the same exact thing as 30 degrees. So all you need to do is just make a mental note that this is really 30 degrees and pi on 2 is really 90 degrees. And we just integrate, right, from that point. So we are going to integrate sine 2x between pi on 6 and pi on 2. Pi on 2 is the bigger one. All right. So, I'm integrating dx. And remember, x is really an angle. So, how do we integrate sine ax? Well, the a comes like the 2. The number here goes underneath the 1 and you get minus cos 2x, right? Let's write it back. When we integrate this, we get minus 1 on 2 cos 2x. And then we put the big square brackets here. And you put pi on 2 and pi on 6. But you know this is really 90 degrees and this is really what? 30 degrees. So we have to put this inside here and then put this inside here and minus both answers. So let me write this out. Give me a few seconds here. Minus a half cos 2x. Put it in a big square brackets here. Minus, I'm going to write back the same thing. Minus a half cos 2x, right? We are going to replace the first x with 90 degrees. So when I replace this with 90 degrees, 2 by 90 is 180. So you're already going to cosine 180. And we're going to replace this x here with the 30 now. So erase it, put 30. 2 by 30 is 60 degrees. So all we need to do is work this out, multiply the answer by minus a half, work out cos 60 and multiply the answer by minus a half, and then minus both answers, and we'll be finished. All right. Let's see. Cosine 180 is minus 1. Cosine 180 is minus 1. Minus 1 by minus a half is positive a half. You have a minus sign here. That's this guy here. Cos 60. Right? Cos 60. Cosine 60 is a half. A half by minus a half is minus a quarter. Right? Right, so cosine 60 is a half by a half is a quarter, and don't forget the minus sign here. And of course, the two negatives, this negative and this negative, come together. So a half plus a quarter, because two negatives touch, will give us 3/4. So that means the area of this region is 3/4 units. Not bad, not bad. Let's try a harder trigonometry question. This one's pretty, well, wasn't that easy, but it's easy-ish, I guess. Alright, let me double check that time on the camera. These videos are getting longer and longer. It's easier for me to make one long video and edit it in one shot rather than make a whole set of small videos and edit each one separately. So I guess the reason for these long videos is my laziness, I guess. All right. Well, you can always pause and save the position in YouTube. Oh no, I just drank water and I didn't do the cards thing. Oh well. Alright, let's move to our next question here. Alright, let's say we have another graph now. Another trigonometry graph. Not too sure how this graph will look, but let's say it looks something like this. Alright, let's say the equation of this graph is y is equal to 2 plus cosine, we'll make it a little bit harder, it's too easy, plus 1/3 cos 2x plus pi on 2. Alright, this is going to be a challenge. Cool. So just don't forget pi on 2 is a constant, and pi on 2 is really how much degrees? 90 degrees. Right, so let's I didn't tell you which region we wanted. Let's say it's from 0 all the way. Let's assume here is pi on 3. And we want the area between 0 and pi on 3. So remember, I never told you what pi on 3 was, but pi on 3 is really 60 degrees. So I'm letting you know that now. You can make a note of it. And pi on 2 is 90 degrees, right? So I shouldn't have erased that. So pi on 2 is 90 degrees, right? So let's integrate. Let's head on to this. Integrate 2 plus 1/3 cosine, open brackets 2x plus pi on 2. And it's dx, and this whole thing is supposed to be in brackets. I'm not going to put it. It's just going to make the question look more complicated than it should be. So let's integrate. This 2 is completely separated from these two guys. So when you integrate 2, you will get, 0 and pi on 3 are the limits, because we want to find the area between 0 and pi on 3. When you integrate 2 is a constant, you will get 2x. Plus, when you integrate cosine, right, you get sine, and whatever is touching x goes underneath. So the 2 will go underneath the 1 here, but here has a 3 waiting. So 1 and the 3 and the 2 will go underneath. 3 by 2 is 6 sine, and then we write back the same exact thing in the brackets, 2x plus pi on 2. Okay, so I hope you understood that integration there, right? I had shown you how to integrate this in the previous video. Right, I have to put my big square brackets because we are finished integrating. Now the 2 things are supposed to go here, the 2 limits, but I don't have space there. So I'm just going to write it here, right? But it really belongs on that side. So here's what we're going to do. We have to replace all the x's here with the top limit, and then all the x's here with the underneath limit. Don't rush this question. The reason I chose this question was for a very special reason. We all know, well, by now, pi on 3 is 60 degrees. And well, 0 is just 0 degrees. You can't do anything about that. When we are replacing this x, you see how this x here belongs to the sine? We are going to replace this with 60 degrees. And we know pi on 2 is really 90 degrees. So when we're replacing it inside here, we could use the degrees, not a problem. But when we are replacing him, he is not connected to a sine or a cosine. He is not a trig function. So when we replace him, we actually replace him with the fraction pi on 3. A lot of students get confused about that. So only when you're replacing it as part of a trig function, then you use the degrees. If he just replacing a normal x and he's not connected to sine, tan, or cosine, you just actually put the fraction the examiner gave you. So let's work through this here. I'm gonna write. Give me a 2 minutes to give me a minute just to write this. See if you can work this out before me. All right. I'm gonna put in 90 degrees here. That's gonna make me more comfortable. One-sixth sine 2x plus 90 degrees. All right. So let's pay attention to the pi on 3, which is really 60 degrees. When we replace this x, we are really replacing it with pi on 3. When we are replacing this one, we're going to use the degrees substitution, 60 degrees. Over here, it's just 0. That's this guy. And the angle here is still what? 0. Right? Right? 0 radians is the same thing as 0 degrees. We just have to work it out now. Let's see. Well, this should be easy. I'm going to leave everything as fractions just to the end. 2 by pi on 3 is really 2/3 pi. 2 by 60 is 120. We have to add it to the 90 and then sign it and then multiply it by the 1/6. So let's see. 120 plus 90 is 210. I have to sine 210 degrees. Sine 210. Hey, we got a good number. Let me double check that, right? 120 plus 90, and we have to sine that. Hey, we got a really nice number. I really didn't expect to get a nice number. When we work this out, we got minus 0.5. Now we still have to multiply that by 1/6. Multiply by, that's not 1. All right, so if we take this and multiply by this, we get minus 1/12. I don't know why I used my calculator for that. That should have been obvious to me, but sorry, the days are getting longer and I am getting thirstier. All right, minus 2 by 0 is 0. 2 by 0 is 0, and then we have to add 90. So sine 90 is 1, and we still have to multiply it by 1/6. So we 1 by 1/6 is 1/6. Multiply by 0 is still 1/6. We just need to work this out. So we have 2/3 pi minus 1/12 minus 1/6. So let me work this out here. Negative 1/12 minus, hey, got a nice number. When we work out this, we get minus 1/4, and we have 2/3 pi. I would leave my answer like this for the examiner. Or if you want to put it as a decimal, you can say 2/3. 2/3 multiplied by pi, I can't find my pi button, minus 0.25. If you were to work this out on your calculator, you will get 1.84. So the area of this region is 1.84 units squared, or you could write this instead. Some textbooks will have this as the final answer. Some textbooks will have this as the final answer. All right, this was a long video. I think I deserve water, and I deserve 6 picks. Let's see how my luck turns out today. None. 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 Aye. Oh, yeah. Okay. Jeez. All right, no water for me. Okay, guys. Anyway, in this, I think this is video 2. In my next video, I'm going to do something called volumes of revolution. So far, we only did areas. I have to show you how to calculate volume using integration. So, until my next video, take care. Hi, good day, and welcome to my next video on integration. Today, I'm going to be showing you how to calculate volumes of revolution. Just think of it, forget the word revolution, and just say volumes. So, in my last video, I showed you how to calculate the area. Today, volumes. So let's jump right into it. To the right here, we have the formula. That's a pi you're seeing there. Pi, you're integrating, and that's a y squared you are seeing there. And then we have a dx, which means we are going to be integrating the letter x. So I already drew up our first situation. Let's assume that we have a graph, and the graph, this is the equation. Y is equal to 4x cubed minus 2. And we are interested in the areas, the region 1 to 3. And obviously there must be an area here. But if this area were to rotate about the x-axis, so pretend it's like a fan, it's spinning about the x-axis, you will get a shape, and that shape would have a volume. So I'm going to show you how to calculate the volume of that area. Now you notice there's two ways this could spin. This could spin about the x-axis, or this could spin about the y-axis. Spinning about the y-axis, as far as I know, it's off the syllabus. So we'll be only concentrating on spinning about the x-axis, and that's the formula for the x-axis rotation, not the y-axis rotation, which I believe is off the syllabus. So there's a squared here, so pay attention to that square. And let's try this question here. To find the volume, we have to say pi, integration sign. I guess you know what goes here and here by now. That's the limits, the 1 and the 3. Smaller number goes underneath, bigger number goes to the top. But we have a y squared. So we have to put the value for y. Y is equal to 4x cubed minus 2. So 4x cubed minus 2. And don't forget, we have to square this entire thing. Only after squaring it and simplifying it, then we will integrate it. Now, you all remember what squared means? Squared means yes, two brackets next to each other in this case. So I'm just going to do a little bit of side work in here, and then we'll put the answer over here. So let's do the side work in here now. 4x cubed minus 2 squared is this. Multiply by itself. Right? So in case you can't remember how to do this, you block this guy here. Let me use my hand, it's a little bit smaller. We multiply both of them by 4x cubed. And then we block him and multiply both of them by minus 2. So let's try this one. Let's do this one first. Multiply both of them by 4x cubed. 4 by 4 is 16. X cubed by x cubed is x to the power 6. 4x cubed by minus 2 is minus 8x cubed. I think I made no mistakes there. Alright, let's try this one. Minus 2 by the 4x cubed is minus 8x cubed. Minus 2 by minus 2 is positive 4. You have a minus 8x cubed and a next minus 8x cubed. This could combine to give you a minus 16x cubed. So, let's put the answer up here. Pi integral 1/3 16x to the power 6. These two combine to give you a minus 16x cubed plus 4. And well, you have to put a little dx here. Alright, So now it's time to integrate after squaring it. And whatever we get, see, after we integrate this and we get our answer, we just have to multiply the final answer by pi. And that's how we find the volume. So let's get started on the integration part here. Right, I don't expect to get nice numbers. This is something I made up on the spot. So how do we integrate? We add 1 to the power, divide by the new power. So add 1, 6 plus 1 is 7. Add 1, we end up dividing by 4. This is a constant by itself, so I have a good feeling we're going to end up with 4x here. Right, so let's put that over here. Oh, by the way, 4 we could go into 16 4 times. So I think my final answer will look, well, sorry, I shouldn't say final answer. We have finished integrating, but when we integrate, we still have to plug in the 1 and the 3. So it will look something like this. And let me see, I run out of space here. So 16x to the power 7 divided by 7 minus 4x to the power 4. Remember, we divided 16 by the 4 to get 4. And we had added the power. And when we integrated 4, we got 4x. Right? We got 4x there. We still have to put the big square brackets, put the 3 and the 1. And we have this pi waiting on the outside. So we're going to work out this part here first. Simplify the whole thing, and whatever we get, we just multiply by pi. So let's forget that pi for the time being, right? All right. Let's work this out here. So give me a, you know the procedure by now. Yeah, give me some time to write this out. I like to work out everything in full. Oy. Right. You could try working it out before me. Put this in our big square brackets. Minus, right back the same exact thing. 16x to the power 7 divided by 7. Minus 4x to the power 4 plus 4x. Right. Of course, we have to replace all the x's here with 3. And then all the x's here with 1. And then minus both answers. So we have x to the power 3. Replace this x with 3. Please don't forget to put your brackets when you are replacing things. And over here, replacing all the x's with 1. I have a good feeling we're going to get some scary looking numbers just by looking at that anyway. Alright, but I can't blame anybody. I made up this question. Do not make the mistake and say 16 by 3 and then put it to the power 7. It's 3 to the power 7, then multiply by 16. So 3 to the power 7 multiply by 16 divided by 7. Whoa. Crazy answer here. 4,998.86. Whoa. 3 to the power 4 multiply by 4. 3 to the power 4 multiply by 4. This one wasn't too bad. Minus 324. And 4 by 3 is 12. My mandatory minus sign here. This one is easy. 1 to the power 7 is 7. Sorry. 1 to the power 7 is 1. 1 by 16 is 16. And then you have to divide it by 7. So we are going to get 2.29. 1 to the power 4 is 1. 1 by 4 is 4. 4 by 1 is 4. Alright. Let me work this out here. 4,998.86. Making sure that's correct. Minus 324 plus 12. We get 4,686.86. Minus 2.29 minus 4 plus 4. Well, this should have been obvious. I know why I worked that out. This and this would have cancelled out. So we just minus these two answers. 4686.86 minus 2.29. Sorry, running out of space here, so I'm just gonna put it here. Is 4684.57. And this entire answer, remember I told you that when we worked it out according to the formula, we have to multiply by pi. So we could put pi here, and of course it would be units cubed because it's volume. Or you could take this and multiply by pi and get a decimal. So you get 14717.01 units cubed. This is correct and this is correct. Some textbooks leave the answer in terms of pi, and some textbooks will just multiply it out. Let me just check the camera to make sure that the bottom line didn't get cut off in the camera. Nope, everything is over there. Let's try our next example now, right? How to find the volume when it's rotated about the x-axis. All right. This time it's going to have two graphs. So we'll see how the question changes when it have two graphs. Okay. It's not going to change that much, but there will be a change. All right. Let's see. I'll check the time on the camera. It's going good so far. All right. Let's see. X and Y. Let's say we have two graphs. Let's say we have one looking like this, and the equation is y is equal to 4x square root, right? Nothing is wrong with that. And there's another graph. Oh, well, make some more space here. Y is equal to 2x squared. And if you notice, in between the two graphs, there's an area. What I want to know is if I rotate that area, only the green part about the x-axis, what volume I will get. Now, whenever you have to find a volume created between two graphs, all you have to do is take the two equations, right? It's basically the second graph minus the first graph squared, right? You integrate it between the two regions, and then you multiply the answer by pi. So you have to figure out which one goes first. Remember when we were finding the area I forgot one thing. We need to figure out where these two graphs meet, because we know here is 0, that's the origin, but we don't know where those two graphs meet. So we need to figure out that. And the only way to do that is to solve them simultaneously. So I guess I have to solve these two things simultaneously to figure out the other x value. Oh Lord, I didn't predict this. But we're going to do it. And after we do that, we're going to throw it into this formula. So at the end of the day, we're squaring the first graph. You have to square the one that's on top in the required region. That's the red one. We are going to square the red equation. And then we are going to square the blue equation. And then we are going to minus it. Right? And after we minus it, then we will integrate it. And then multiply the answer by pi. Alright, so let's get started here. Let's figure out where these two graphs meet. Over here is supposed to be 0, so I guess when I do my calculation, it should look like 0. And we need to figure out this one here. Alright, so the first equation, the blue one, is y is equal to 2x squared. And the red one is y is equal to 4x square root. What I'm going to call this equation 1, equation 2. So I'm guessing anywhere I see a y, I can replace it with 2x squared. So I'm going to go to the second equation. Look, there's a y here. Throw him away and put 2x squared is equal to the 4x square root. Here's what I need to do now. To get rid of the square root, I probably need to throw him across on the other side. When you throw across a square root, you will get the opposite. You will get a squared. which means that everybody here gets squared. 2 squared is 4. X squared is x to the power 4 is equal to 4x. Remember, the square root sign doesn't live here anymore. We are threw him out on the other side. So let's solve this equation. Let's throw everyone on the same side. We have 4x to the power 4 minus 4x is equal to 0. It seems to me that we can factorize out 4x. So if we factorize out 4x, we get x cubed minus 1 is equal to 0. That looks about correct. We put each portion equal to 0. Let me put it here. So 4x is equal to 0. And at the same time, x cubed minus 1 is equal to 0. If we solve for x here, throw across the multiply, you'll get divide 0. So our first value was 0. Let's solve for x in the second equation. Throw across minus 1, you get positive 1. And then you cube root the 1. Because when you throw across a cube, you'll get cube root. So the cube root of 1 is 1. I'm really happy we ended up with a nice number here. Alright, so in the exam, if they don't give you the limits of the shaded region, you're going to have to solve them simultaneously to figure out where the two graphs actually meet now. So you get your limits. Alright, so this is unnecessary now. Let's move on to the actual question. To find the area, we have to take the graph that's on top in the required region, not outside the region. In this region, it seems that the red one is on top. So we have to take the red equation and square it. So we will get 4x square root, and it gets squared. And now we have to minus the other equation, the one that's underneath. So the one underneath is the blue one. Let me color code it. Minus 2x squared. Write this better for you guys. And this whole thing has to get what? Squared. Alright. So what we're going to do is square this, and if it could simplify, we would simplify it. I have a pi lurking on the outside, and the two limits are 1 and 0. In case you didn't know, when a squared and a square root bounce up, well, remember, if you have a square root, let me say I have a square root, and you have a squared on the outside, square root is the same thing as to the power half. Whenever you have two powers separated by brackets, you multiply them. A half multiplied by 2 is 1. We don't even need to put the 1 because the 1 is understood. So when we square this, we're only going to end up with 4x in any case. The square and the square root will cancel out. So let's see where we end up here. So we're going to end up with pi or integral 0, 1, 4x minus everybody in this brackets gets squared. 2 squared is 4. X squared squared is x to the power 4. We just have to integrate this. Alright? So let's integrate and see what happens. Alright. So this is really x to the power 1. Lord, this is a long question. I'm going to continue working here, right? So it's 4, add 1 to the power, divide by the new power, which will be 2. Add 1 to the power, divide by the new power, 5. So we end up with 4x squared divided by 2 minus 4x to the power 5 divided by 5. And we're going to put our big square brackets here now. Put 1 and 0. And don't forget the pi lurking on the outside. Okay. 4 divided by 2. Let's simplify that to 2 one time. Let's not make an issue out of that. So here's what I want you to do. Replace everyone here with 1, work it out, and then replace everyone here with 0. Work it out, minus both answers, and when you minus both answers, multiply it by pi. All right. So let me write it underneath here. Let's see if I could clear up some space. Yeah, make this a little bit smaller. Alright, cool. This should work now. I'll deal with this pi after. I really don't care about him now till the end of the question. So see if you can work it out before me. Alright, give me a few seconds. You know the drill by now. Bam, bam. 2x squared minus 4/5 x to the power 5. Alright, replace both x's here with 1. All the x's here with 0. This one's going to be easy here because anything multiplied by 0 is 0. So I know this side is going to boil down to 0 anyway. 1 to the power 2 is 1. 1 by 2 is 2. 1 to the power 5 is 1. 1 by 4/5 is 4/5. Of course, we have to minus the 0 here. 2 minus 4/5 should be, well, I'm running out of space here. 2 minus 4/5 is, clear a little region here, is 1 and 1/5. Okay? And we still have to multiply that answer by pi. Units cubed. Right? Or you could just take the calculator and say pi multiplied by 1.2, because 1 and 1/5 is the same thing as 1.2. And you should all get 3.78 units cubed. And that's how you find the volume between two curves if they were to rotate about the x-axis. I hope you have a good imagination. This whole thing is just going about the x-axis, rotating like a motor or a fan. Well, a fan has a motor, right? So I really hoped that this cleared up how to do volumes. All right, in my next video, I have to show you some volumes of revolution involving trigonometry, like sine and cosine. Also, I didn't show you everything, like every single situation, on how to integrate sine and cosine. There are a lot of trick questions that I want to go through with you in the next video. Questions that I'm pretty sure will find its way on a past paper. So for my next video, stay tuned for it, and we'll have a good day. Hi, good day, and welcome to my next video on integration. Today I'm going to be doing, well, I guess the integration of very strange questions that always kind of like find their way on a past paper. So I'll basically call it trick questions. So let's get started right away. I already laid out your first question. I'm giving you a graph, and the equation of the graph is y is equal to sine squared x, and I want you to find the area of the shaded region, the green region. Now here's the thing. When it comes to trig functions and you want to find the area, well, if you want to find the area, you know it's an integration question. So you want to integrate between 0 and pi on 4. Now pi on 4, I am letting you know this is radians, because when it comes to like sine, tan, and cosine, the examiner will most likely give you the angles, because sine, tan, and cosine are made for angles. Pi on 4 is really 45 degrees. Okay? Right? So I'm letting you know that up front. So this is the radians and this is the degrees. So we are going to integrate sine squared x between 0 and pi on 4. Now here's the thing. Most likely you think you know how to integrate sine squared x. Let me explain. Remember when I was doing these videos and I told you that when you're integrating sine x, you get cos x, so actually minus cos x. If you integrate sine ax, you get minus 1 on a cos ax, right? So if here was 2, over here would have been 2, and here would have been 2. If you were to integrate sine ax plus b, where b is just a normal number, a constant, you will get minus 1 on a cos ax plus b. You write back the same exact thing here. Nowhere in any of these formulas you see a squared here, but today's question has a squared. So here's a mistake a lot of students make, and I need to show you these mistakes. If I ask you to integrate x squared, I know what you would do. You would add 1 to the power. So you add 1 to the power, you will get 3. And then you divide by the new power. And this would be 100% correct. I have no problem with that. But when it comes to trigonometry like sine, tan, and cosine, the rules change up a bit. This is what a lot of students do when I ask them to integrate sine squared x. They add 1 to the power, so they get sine cube x, and they divide by the new power. This doesn't work for trigonometry. Trigonometry have its own set of rules. You can only right now integrate when there's no squared or no power on top, like there's no squared or no cube or no to the power 4. You need the power here to be 1 for you to integrate. So here's the problem. You will probably never get out this question unless your teacher already did the topic called trigonometry with you. It's something called trigonometry identities. That's a topic that you need to cover. I'm not going to cover the whole topic today, but I'm going to give you the parts of the topic that will help you figure this out. There's a formula you need to remember. And here's the formula, right? I always get trouble remembering this formula. I'm not too sure why. Cos 2x is equals to cos squared x minus sine squared x. You need to learn off this formula, right? Now, this formula has other versions. Cos 2x is also equal to 2 cos squared x minus 1, and cos 2x is also equal to 1 minus 2 sine squared x. Okay? You need to learn this off. This means that anywhere you see this, you can replace it with this. Anywhere you see this, it's okay to replace it with this, and similarly for this one. So let's see what we can do. We don't know how to integrate sine squared x, but from the formulas I just gave you, I could transpose this sine squared x. I could transpose this to make sine squared x the subject. So here's what you need to do. You need to throw across, well, there's two ways you could do this. I could throw across the minus 2 sine squared x on this side, and the positive cos 2x on the other side. I think I'm going to do it like that. It might be a little easier. So throw across the whole minus 2 sine squared x on this side to get positive 2 sine squared x. Throw across the positive cos 2x on the other side, you get minus cos 2x. Right? Don't mix up 2 and squared. They're completely different. Right? We're almost there. The 2 is a multiply, throw it across, you will get a divide. Right? So if I made sine squared the subject, this is what I would get. which means anywhere I see sine squared x in ADMATS or maths in any case, I'm allowed to throw it away and replace it with this. So let's try this. The examiner asks us to integrate sine squared x. We don't know how to integrate sine squared x. So I am going to erase the sine squared x and replace him with 1 minus cos 2x divided by 2. Now, when I'm integrating, I need for everyone to be separated. Everyone here is grouped, but I know this really means everyone on top gets divided by 2. So I can erase this divide sign and divide everyone individually by 2. Now let me explain another problem students encounter. If I have 2y divided by 2, I know I could cancel out that 2 and that 2, right? Now that's something we are accustomed doing. So here's the problem. When it's cos 2x, I'm gonna write this better. When it's cos 2x divided by 2, they go wham wham. They divide it out. That's not allowed in maths. Cosine, they see sine, tan, and cosine trigonometry, they follow a slightly different set of rules. If I have 2 cos 2x divided by 2, this 2 and this 2 could divide out. Not when it's inside or in front. Remember, this 2x belongs to the cosine. Whatever is here will eventually be cosine. You can't interfere with that. If he's on the outside, not a problem. You can divide it out. I have no problem with that. So the point I'm making is, don't divide this and this. Please don't. Another way of writing this, when you're dividing something by 2, this is the same thing as a half. So you could rewrite this equation as a half cos 2x if you wish. Right? So I'm just going to put the half here. So it will be a half cos 2x. The 2 already belongs, and when you multiply something by half, you're already dividing it by 2. So let's integrate this now, right? So let's give me a few seconds and take a drink of water. All right, I'm back. Okay, that's, oh, by the way, pi on 4 is really 45 degrees for us. When we integrate a number by itself, a half, we're going to get a half x. Remember, if we integrate 5, we get 5x. If we integrate 3, we get 3x. If we integrate a half, you just get a half x, right? When you integrate cosine, by now you should know we get positive sign, right? Now we have a negative sign here, so a positive and a negative will still give us a negative. And whoever is touching the x will jump underneath the 1. Now it has a 2 weight in here, so the 2 multiplied by the 2 will give us a quarter. We integrate sine, we get, cosine, we get sine 2x. We put our square brackets, okay? So 0 and pi over 4, and we know pi on 4 is really 45 degrees. So I guess what we're going to do now, we're going to replace all the x's here with the top value, all the x's here with the underneath value, right? So I'm taking off this. Guys, write this down before, pause the video and write it down. You need to learn this all for the exam, not only for this topic, but for the topic of trigonometry, which will be one of my videos, series of videos eventually. You see, these differentiation and trigonometry, those are the two long, to me, it's the two longest topics. I could see those videos overall being up to 4 to 5 hours long, right? So eventually I'll reach there, guys. I'm going to reach here to help you out. Don't worry. All right. So let's see. Let me write, well, you know the procedure. Let me write this out. A half x minus a quarter sine 2x in brackets. My mandatory minus sign. A half x minus a quarter sine 2x. Right. We're going to take the top one first. Throw it inside here. Remember, I told you, when you are throwing it inside here, if it's connected to a sine or tan or cosine, you put in degrees. If it's not connected to a sine, tan, or cosine, you put in the fraction, the radians, the pi on 4. So for this guy, he is going to be pi on 4, and he is going to be 45 degrees. Right. Now time to put in is 0. 0 is 0, whether it's radians or degrees. Really don't matter. It's just 0. 0, 0. Now here's going to be real easy. I'm telling you one time. 2 by 0 is 0. Sine 0 on your calculator will give you 0. 0 multiplied by anything is 0. And a half by 0 is 0. So this whole thing going to boil down to 0. Let's try. Well, this one is easy. 1 by pi is pi. 2 by 4 is 8. Sine, well, 2 by 45 is 90. So let's sine the 90. Sine 90 should give us 1. Let's see it here. Sine 90 is 1. 1 by a quarter is a quarter. And this is our answer because we have to minus 0 from it. But that's not going to make a difference. Units squared. Some textbooks will leave the answer like this. And some textbooks will work it out. So let's work it out. Pi divided by 8 minus a quarter, which is 0.25. This is also an acceptable answer in the exam. 0.143. Well, I went to 3 decimal places. Doesn't really matter if it's 1 or 2. I have to double check for which one the CXC math syllabus ready ones. I'll go to 3 just in case in the exam. Right? I'm not too sure, but I'll find out, and well, in one of my videos I'll make a mention of whether we should go to 2 decimal places or 3 decimal places. That isn't too important right now. Alright, so I showed you a trick question. Let's check the time on this. I don't know why the time is so hard to see on this. 14 minutes. Oi. Think we have time to do our next one? Let's try our next one. Alright. This thing is shifting. Is everything still in camera? Alright. Okay, let's try another one. Let's try how to integrate pi on 2 and pi on 3 for cos squared 3x. Now, I didn't draw the graph, but we're obviously trying to find the area between pi on 3 and pi on 2 for the graph. So you can probably just imagine we have a graph. I'm not too sure how the graph will look, and you're trying to find the area of a certain region. When you're using limits, you're already finding area in SMART. So, how do we go about a question like this? You notice it has a squared? That's this guy here. Has a squared. We do not know how to integrate a squared when it's attached to a trigonometry function. We don't know as yet. So we have to find a workaround. The workaround is this formula. Remember one of the formulas I put there on the thing? Cos 2x is equal to 2 cos squared x minus 1. Right. That was a few minutes just before this. That was one of the formulas. Now don't get me wrong. If here was p, then over here would be p. So that means if I have, you want cos 3x. So that means, check this out. I'm going to get a different color for you. So whatever I have here, it's twice as big as here because here's p. and over here is 2p. So if I were to erase this p and put a smiley face, then I have to erase this p and also put a smiley face, right? I'm building up to something here. If I erase this and replace it with 3x, guess what? I have to erase this and put 3x. Right. Remember, we need to integrate cos squared 3x. That's the aim of the question, cos squared 3x. So what I should do is make this the subject of the formula and replace it out inside here. So 2 by 3x is 6x. I'm going to throw across the -1 to get +1, and the 2 is a multiply, throw it across to get a divide. And this will give me cos squared 3x. Now I can throw this away and replace it with this. Because I know how to integrate cos 6x. I do not know how to integrate cos squared x. So, let's get started here. Well, I'm guessing by now, well, to give space now, I'm going to erase cos squared 3x and replace it with this guy. Now remember, this really means both of them get divided by 2. So, you have cos 6x divided by 2 plus 1 divided by 2, better known as a half. 6x divided by 2 is 3x. Right or wrong? Wrong. That's something completely wrong. Remember, I told you that when here is 6x and here is 2, if the 6 was here, we could have divided it, but it's not here. It belongs to the cosine. So we have to leave it like that. Or we could put the half in front here, because dividing by 2 is the same thing as multiplying by a half. So this is the expression we should be multiplying. All right, so let's go here. Pi on 2 is the same thing as 90. Pi on 3 is the same thing as 60. All right, so let's integrate now. When you integrate cosine, you get positive sign, right? And the number touching the x will also go underneath and the 1, but it has a 2 weighted. So 2 by 6 will be 12. So when we integrate this, we will get 1 on 12 sine 6x positive. Because when you integrate sine, you get, when you integrate cosine, you get positive sign. And when you integrate a number by itself, you just put back what? The x. You have to put a little square brackets here. Pi on 2, pi on 3. Right? We know this is really 90 degrees, and we know this is really 60 degrees. Remember, when we are replacing it, if it's connected to a trigonometry function, we replace it with the degrees. Trigonometry functions are made for angles. If it's not connected to a trigonometry function, we put in the pi on 2, the actual fraction. So guys, you know the procedure from here. You have to give me a minute to write out this whole thing. I'm sure some of you all will just fast forward by now. I'm sorry, I'm really sorry for the length of these videos. But I have to make the assumption that you really don't know too much in the admaths, right? I've watched a lot of videos online and they skip steps, and I could only imagine how lost some people become, right? So you're sacrificing some of your time to get a proper explanation, I hope. I really hope. All right, so let's replace it inside here. The top one is pi on 2 or 90. think I'm going to erase this x and put a 90. X here, should I put 90 or the pi on 2? It's pi on 2. It's not connected to a trigonometry function. This one is 60 degrees. That's this guy here. X here, we replace it with pi on 3. Alright, calculator time. Where's my calculator? Cool. Take the 6, multiply by the 90 degrees, and we will sine it, and then multiply by 1/12. So let's work that out. 6 multiplied by 90 is 540. If we sine that, 540 seems to give us 0. Sine 540 is 0. So here's 540, and when we sine it, we get 0. 0 multiplied by anything is 0. Over here, well, pi by 1 is pi. 2 by 2 is 4. So you'll get pi on 4 plus 0, which is pi on 4. Put that in little brackets there. Alright, I'm praying I get a 0 on this side to make my life easier. Alright, 6 by 60 degrees. 6 multiplied by 60 is 360. Sine 360 is yes! Sine 360 is 0. Yes! Somebody loves me up there. 0 by anything is 0. Plus 1 by pi is pi. 2 by 3 is 6. Great! What a perfect end for a Sunday. Yes, it's a Sunday right now. The time is 25 past 5, and I am here making videos while all my friends are liming and having a good time. Great. 0 plus pi on 4 is pi on 4. Minus 0 plus pi on 6 is pi on 6. We just need to, you can leave the answer like this, right? No, let's not leave the answer like this. Let's simplify this. So, pi on 4 minus pi on 6. When you work this out, you will get 0.26 units squared, right? Let me work it out so you have your answer in terms of pi. Have some space here. Pi on 4 minus pi on 6. LCM is 24. 4 into 24 is 6. 6 by pi is 6 pi. 6 into 24 is 4. 4 by pi is 4 pi. You will get 2 pi on 24, or pi divided by 12. The 2 into 24 now is 12. I'm going to double check this. Yes, my answer is correct. Both these answers are correct. I believe you'll find this one in the back of your textbook since it was so easy to simplify. Alright, so those were some trick questions involving trigonometry that can sneak its way into a past paper. Alright, so in case you didn't know, these videos were already made for like CXC past paper questions, right? Not the GCE past paper questions. To me, the GCSE, if I'm not mistaken, past papers are way harder than the CXC past paper questions, right? So if you're from like England and you're watching these videos would not completely prepare you for the GC examination, just probably the CXC examination, to be honest. All right, I don't want to set you up. All right, guys, take care. I'm not too sure if I'm going to do any more videos on integration. I believe this is the end. So the next topic I'm going to do is either APs and GPs or logarithms. Take care.